Hello, my name is Tafazona Shekari. I'm the founder and business developer for Umoja Lens System. So at Umoja Lens, we are solving food security through big data analytics and artificial intelligence. So this means that we are using satellite imagery to drive recommendation on how to improve crop yields per farmer, and this is a case study for Pfumvudza farming. We all know that Pfumvudza was done on a traditional basis, but today we want to talk about precision Pfumvudza farming as a concept, and the traditional basis was executed by the government of Zimbabwe, and the precision Pfumvudza, it will be done by the government of Zimbabwe in partnership with Umoja Lens. So this means that every aspect of precision Pfumvudza farming, there will be data that is generated from satellite imagery and machine learning, and we are now doing fertility mapping before the government has invested in fertilizer. So by dealing with fertility mapping, it means that smallholder farmers must prepare their field by adding up nutrients that can neutralize the pH level, that can increase carbon content and organic matter in the soil, etc. So this is a case study for Chivhu, Sikombi, and this is where Pfumvudza was done in Chivhu. So we all know that Pfumvudza, it's 50 plants in 52 rows, meaning that in each row we have 50 plants, so that the farmer can get 20 liters of bucket in a row times 52. So it means 52 bucket that can sustain a farmer for 1 year. But in Chivhu, in Sikombi, farmers did yield 5 liters and below of bucket in each row, meaning that it's not because that inputs were poor. No, the inputs was really brilliant, but it's because extension agents and the farmers are still using legal farming method, and due to climatic factors, climatic change, and also extension agent, they can't visually see other things like water stress in the crop. They don't have real-time data. So we are saying this application is good for a farmer to improve crop yield per given area. So we can say there is 5.9% level of pH and carbon content is 5, organic matter 8.6, and the 0.7 hectares, it's dominated by sand is 66, clay 25, silt 10%, and the soil is slightly acidic and okay for most crops. However, it also means that a farmer must apply things like ash and other acid neutralizing. So before the farmer receive the Pfumvudza input, the extension agent or the farmer, they must run what we call fertility mapping. So let's say, for example, a farmer is expecting 3 tons of maize per 0.7 area. So we want to see how viable is the farm, and also what are the required nutrients on a particular area. So we can see that the soil fertility is extremely low. As a result, farm is not viable. Investment in fertilizer application without improving soil quality may amount to waste. So a farmer must improve soil quality first before they have received inputs from the government. And also, we now using what we call precision application of fertilizer. The traditional aspect where Pfumvudza was done is to add lime in each hole. But however, now with big data analytics, we are now able to identify where soil is fertile, moderate, and infertile. And where soil is fertile, we just need 8.35 kg or only 0.28 hectare. And where the soil is infertile, we need 33 kg on a 0.37 hectare. So this is our intelligent fertility map where Pfumvudza was done previously. But when we are now using the precision way, we can now identify where to take action. Like the shaded green, it shows where the soil is fertile, and the light green, it shows the where the soil is infertile, and the yellow, it shows where the soil is infertile, 100% infertile. But however, the light green, it's moderate. So we can now understand that, okay, the fertilizer required where the soil is fertile and the fertilizer out of the lime required where the soil is infertile is much different. So by so doing that, a farmer can now prepare the land on the where the soil is infertile, where they are waiting for Pfumvudza inputs to be carried. But however, there's still life after Pfumvudza. They still need to manage the crop after Pfumvudza. So a farmer can still use this application to monitor water stress in crops, to monitor water stress in soil, that is soil moisture, and to check the phenolphase level. And right now, there are no crops, but there are grass. Here, there's strawberry here. So let us check water stress level in crops. Then we do understand what the farmer can do. This is because there are no crops at the moment. That's why you see return glands, it's zero. But if there is a crop, it can show the water stress level content in the crop, and the application can advise on irrigating or whether to stop irrigating, so that they can really maintain the level or the amount needed by maize at a particular stage. Right. Thank you.